The calculate function in is one of the most powerful and flexible functions in Power BI and other tools that use the language like Power Pivot and SSA Tabular. It allows you to modify the context in which a calculation is performed by applying filters to a specific expression. Syntax: calculate expression, filter 1, filter 2. Expression: this is the calculation or aggregation you want to perform, such as sum, count, average, etc. Filter: one or more filters that alter the context for the calculation. These filters can be column filters, table filters, or other functions like all, filter, or relatable. Key features of Calculate 1. Modifies the filter context. Calculate changes the current filter context for the calculation of the expression. 2. Implicitly performs context transition. When used in a row context, Calculate automatically converts row context to filter context. This is key for using calculated columns or measures. 3. Allows multiple filters. You can apply multiple filters at the same time, which either replace or modify the existing filters. Basic examples: Example 1. Simple use case with sum. Assume you have a table called sales with columns, sales amount, and region. You want to calculate the total sales for a specific region, say North America. Total sales not equal calculate sum sales amount, sales region equal North America. In this case, calculate is summing up the sales amount only for the rows where region is North America. Example 2. Filtering with multiple conditions. Now, suppose you want to calculate the total sales for both North America and Europe. Total sales not EU equal calculate sum sales amount, sales region equal North America, sales region equal Europe. Here, the calculation only includes sales from both North America and Europe. Advanced scenarios. Example 3. Ignoring existing filters with all calculate allows you to override existing filters. For example, if your visual already filters data by region, but you want to ignore those filters, you can use the all function. Total sales or regions equal calculate sum sales amount, all sales region. In this case, any filter on the region column will be ignored, and the total sales across all regions will be calculated. Example 4. Filtering with time intelligence functions. You can use calculate with time intelligence functions like dates, YTD, previous month, etc. to compute period-over-period comparisons. Example: year-to-date sales YTD sales equal calculate sum sales amount, dates YTD datable date. This calculates the year-to-date YTD total sales using the dates YTD function, which modifies the filter context to include only the dates from the start of the year to the current date. Example 5. Using filter inside calculate, you can use the filter function inside calculate to create more complex filtering logic. Example: sales over a certain threshold high value sales equal calculate sum sales amount, filter sales amount 1000. Here, the filter function limits the rows to those where sales amount is greater than 1000 and then calculates sums the sales amount for those rows. Combining filters. Example 6. Multiple filters calculate allows you to apply multiple filters at once. The filters are combined using logical and by default. Example: total sales for North America in 2023, total sales not 2023 equal calculate sum sales amount, sales region equal North America, sales year equal 2023. In this example, calculate will sum sales amount only for rows where region is North America and year is 2023. Calculate and row context. Example 7. Context transition. Calculate plays an important role in measures because it transitions from row context to filter context. This allows you to aggregate data based on the current row of a table. Example: calculated column with calculate. If you want to calculate a bonus based on total sales for each salesperson, you can use a uCalculate table. The calculate table function in is very similar to calculate, but instead of returning a scalar value such as a sum or count, it returns a table. This function is particularly useful when you need to filter or modify the context of a table that will then be used for other calculations or operations. Syntax: calculate table, filter 1, filter 2. Table: the table you want to apply filters to. Filter: one or more filters that modify the filter context for the table. Key features of calculate table 1. Returns a table. Unlike calculate, which returns a scalar value, calculate table returns an entire table that can be further used in expressions or visualizations. 2. Modifies filter context. Like calculate, it allows you to apply or modify the filters on the data. 3. Enables advanced table calculations. You can use calculate table for complex scenarios like generating dynamic tables based on different filter conditions. Basic example 1. Returning a filtered table, assume you have a sales table with the columns sales amount and region. You want to create a new table containing only sales from the North America region. North America sales equal calculate table sales. Sales region equal North America. This returns a table with only the rows where the region column has the value North America. Example 2. Applying multiple filters. Let's say you want to return a table with only sales from North America and only for sales that occurred in 2023. Assuming you have a column sales date, you can apply multiple filters like this. NA sales 2023 equal calculate table sales. Sales region equal North America. Year sales date equal 2023. This returns a table with sales that occurred in North America in the year 2023. Example 3. Using calculate table with functions, you can combine calculate table with other functions like summarize, filter, or all. For example, suppose you want to return a table that shows total sales by product category, but only for regions North America and Europe. Sales by category NAU equal calculate table summarize sales, sales product category, total sales, sum sales amount, sales region in North America. Europe. Here, calculate table is used to filter the results of the summarize function, which creates summary table grouped by product category with a calculated column, total sales. Example 4. Using all with calculate table. The all function removes filters from a column or table. You can use it in combination with calculate table to ignore certain filters. Suppose you want to return the total sales across all regions, regardless of any current filter context applied on the region column. All region sales equal calculate table sales. All sales region. This returns a table with sales data from all regions, ignoring any filters on region. Use cases. Use case 1. Dynamic tables for visualizations. Calculate table is useful when you want to create dynamic tables in Power BI visualizations that change based on user interactions or slicers. For example, you can generate filtered tables that change depending on selected regions, years, or product categories in the report. Use case 2. Creating virtual relationships. You can use calculate table to simulate relationships between tables that are not directly related in the data model. For example, you could apply custom filters to return data based on specific criteria from different tables. Use case 3. Advanced calculated columns. Calculate table can be used in calculated columns where you need to fetch or aggregate data from related tables under specific conditions, allowing for advanced calculations within columns. Summary calculate table is a powerful function that allows you to return a filtered table, and it can be used for advanced table calculations, dynamic filtering, and more complex scenarios than calculate. It's commonly used in Power BI when building dynamic visualizations, custom filters, and complex table relationships. The all function is used to remove filters from a column or a table, making it a valuable tool when you want to override or ignore the current filter context in your calculations. This can be useful in scenarios like calculating totals, percentages, or performing comparisons that require ignoring specific filters applied by slicers, rows, or columns. Syntax: all table, all column 1, column 2. All table removes filters from the entire table. All column removes filters from a specific column. All column 1 Column 2 removes filters from multiple columns. Key features of all 1. Removes filters. The primary function of all is to clear any filters that have been applied to a table or column. 2. Modifies the filter context. It can be used inside other functions like calculate to remove filters in specific parts of a formula, enabling more flexible calculations. 3. Useful for calculating totals. Commonly used in situations where you need to calculate totals or perform percentage calculations by ignoring specific filters. Basic examples. Example 1. Removing filters from a column. Suppose you have a table called sales with columns sales amount, product category, and region. You want to calculate the total sales for all product categories, ignoring any filters applied to the product category column. Total sales all categories equal calculate sum sales amount, all sales product category. In this example, the all sales product category argument removes any filters applied to the product category column, ensuring the calculation includes all product categories, regardless of any filters set by slicers or other visuals. Example 2. Removing filters from the entire table. In another case, you might want to calculate the total sales for all regions and categories, ignoring all filters. Total sales all equal calculate sum sales amount, all sales here. The all sales argument removes all filters on the sales table, allowing the sum to include every row, no matter the filters applied in the report. Example 3. Combining all with calculations for percentages. The all function is often used when calculating percentages, such as showing the sales for a particular region as a percentage of total sales. Sales preceding North America equal divide sum sales amount, calculate sum sales amount, all sales region. In this case, sum sales amount calculates the sales for the current region filtered by the context. The all sales region removes any filter on the region column, ensuring the denominator represents the total sales across all regions. The divide function then calculates the percentage. Example 4. Using all in a visual to remove filters from multiple columns. You can also use all to remove filters from multiple columns. Suppose you want to calculate total sales by removing filters from both the region and product category columns. Total sales or regions and categories equal calculate sum sales amount, all sales region, sales product category. In this case, the all function removes filters from both region and product category, so the calculation considers sales across all regions and categories, regardless of any filters applied. Example 5. Using all with all except. A variation of all is all except, which removes filters from all columns except for the ones you specify. This is useful when you want to keep a certain filter, but ignore others. For example, to calculate total sales across all regions, but still respect the filter on product category, you could use total sales except category equal calculate sum sales amount, all except sales product category. This function removes all filters on the sales table except for those on product category. Use cases. Use case 1. Dynamic totals in Power BI. All is frequently used in Power BI when you want to display dynamic totals or percentages. For example, if you have a bar chart showing sales by region, you can create a measure to show the percentage of total sales for each region by using all to ignore the filters applied by the chart. Use case 2. Calculating running totals. You can use all in time-based calculations like running totals or cumulative totals. By removing the filters on certain columns, you can ensure that each row in a table or chart calculates the running total correctly. Use case 3. Ignore slicers in reports. In cases where you want a particular measure to ignore slicers or other filters applied by the user, all can be used to force the calculation to always consider the full dataset, regardless of user interaction. Summary. The all function in is essential for overriding filters and returning a full dataset in a specified context. Whether you're calculating totals, percentages, or working with complex filters, all gives you the ability to remove filters and control how calculations are performed in your queries. It is especially useful for handling scenarios where specific filters need to be ignored while keeping others intact. You remove filters. The remove filters function in is similar to the all function, as it also removes filters from a table or column. However, it's a more intuitive and explicit way to remove filters in Power BI reports, introduced in later versions of to enhance readability. The key difference between remove filters and all is primarily semantic, though both functions operate similarly in most cases. Syntax remove filters, table remove filters, column remove filters, column 1, column 2. Remove filters table removes filters from the entire table. Remove filters column removes filters from a specific column. Remove filters column 1, column 2 removes filters from multiple columns. Key features of remove filters 1. Removes filters from columns or tables. Like all, it clears any active filters from the specified columns or tables. 2. More intuitive name. The remove filters function is often preferred for readability and clarity in reports and calculations because it is more descriptive of its function. 3. Can replace all in many scenarios. Wherever you use all to clear filters, you can also use remove filters. Basic examples. Example 1. Removing filters from a column. Suppose you have a sales table with columns sales amount, region, and product category. You want to calculate total sales, ignoring any filters applied to the product category column. Total sales no category filter equal calculate sum sales sales amount. Remove filter sales product category. In this example, remove filter sales product category clears any filters on the product category column, allowing the calculation to include all product categories. Example 2. Removing filters from the entire table. If you want to remove all filters applied to the entire sales table. Total sales all equal calculate sum sales sales amount. Remove filters sales here. Remove filters sales ensures the calculation ignores all filters on any column within the sales table. Example 3. Using remove filters for percentage calculation. Consider calculating the percentage of sales for a particular region compared to total sales across all regions, ignoring any filter on region. Sales PCD equal divide sum sales sales amount. Calculate sum sales sales amount. Remove filter sales region here. Remove filter sales region ensures that the denominator includes total sales for all regions, allowing you to calculate the percentage of sales for the currently filtered region. Example 4. Removing filters from multiple columns. You can also remove filters from multiple columns by specifying more than one column in the remove filters function. Total sales no region or category equal calculate sum sales sales amount. Remove filters sales region, sales product category. This calculation will remove filters from both the region and product category columns, ensuring that the total sales are calculated without any filters on those columns. Comparison with all removes filters and returns all rows in a table or column, with the added capability of returning a table when used on its own. Remove filters more explicitly focuses on removing filters without returning a table. It is functionally equivalent to all when used to remove filters, but improves readability. When to use remove filters instead of all clarity and readability. Remove filters is often used in place of all because its purpose is more explicit. If the goal is simply to remove filters from a column or table, remove filters is easier to understand in your code. Future proofing. As Power BI evolves, remove filters may be preferred for removing filters in scenarios where you don't need the added complexity of all, which can return entire tables. Use cases. Use case 1. Ignore slicers in reports. If you have slicers applied on a report for region, but you want a calculation to ignore the slicer filter, you can use remove filters. Total sales ignore region slicer equal calculate sum sales sales amount. Remove filters SU. All except remove filters in the remove filters function is similar to all, but it's designed specifically to remove filters from one or more columns or tables. It's often used to explicitly clear filters that were applied through slicers, rows, or other visuals. Remove filters gives more intuitive control for removing filters in certain scenarios, especially when working with complex calculations. Syntax. Remove filters column-table column. removes filters from a specific column. Table removes filters from the entire table. Key features of remove filters. 1. Removes filters. Like all, this function removes filters from a column or table, but it doesn't return all rows like all. It simply clears existing filters. 2. Used within calculate. Commonly used within calculate to control which filters to remove when performing a calculation. 3. Simpler than all. While all removes filters and may impact relationships between tables, remove filters is more straightforward and focused on clearing filters. Example 1. Remove filters from a single column. Assume you have a sales table with sales amount, product category, and region. If you want to calculate total sales while ignoring any filter applied on the region column, you can use remove filters. Total sales, ignore your region, equal calculate sum sales, sales amount. Remove filters, sales region. This removes any filter on the region column, ensuring that the total sales are calculated for all regions. Example 2. Remove filters from multiple columns. You can also remove filters from multiple columns by using remove filters in the same way. Total sales, ignore grand region, equal calculate sum sales, sales amount. Remove filters, sales region, sales product category. This calculation ignores any filters applied to both region and product category. Example 3. Remove filters from an entire table. In some cases, you may want to ignore all filters on a table. You can use remove filters to achieve this. Total sales, all equal, calculate sum sales, sales amount. Remove filters, sales. This removes all filters from the sales table and calculates total sales across all rows. Use case. Handling visual slicers in Power BI. Remove filters is particularly useful when dealing with slicers in Power BI. Suppose you want a measure that ignores certain slicers but respects others. Remove filters can be applied to specific columns or tables to achieve this. All except in the all except function is a variation of the all function that allows you to remove filters from all columns in a table except for the columns you specify. This is useful when you want to preserve specific filters while removing others. Syntax. All except table, column 1, column 2. Table. The table from which filters are removed. Column. The columns that are excluded from filter removal. Filters on these columns are preserved. Key features of all except. 1. Removes all filters except specified. It removes filters from all columns in a table except for those you specify, allowing more fine-grained control over which filters to keep. 2. Used with calculate. Like all, it's frequently used within the calculate function to modify filter context. 3. Efficient for tables with multiple columns. Instead of listing out columns to remove filters from individually, all except lets you define just the ones you want to keep. Example 1. Keep filter on one column, remove other. Suppose you want to calculate total sales while keeping the filter on the product category column, but removing filters from all other columns in the sales table. Total sales except category equal calculate sum sales, sales amount, all except sales, sales product category. In this example, the calculation respects the filter on product category, but any other filters like those on region or sales date are ignored. Example 2. Keeping filters on multiple columns. You can specify multiple columns to retain filters while clearing others. Total sales except region and category equal calculate sum sales, sales amount, all except sales, sales region, sales product category here. Filters on both region and product category are kept, but any other filters are removed. Example 3. All except in dynamic visuals in Power BI. All except can be useful in visuals where you want a specific measure to respect some filters but ignore others. For example, in a matrix visual where rows represent product category and columns represent filter, the filter function in is used to return a table with filtered rows based on a specified condition. It is one of the most powerful functions in as it allows for row-level filtering, which can be used in complex calculations. Unlike all or remove filters, which remove filters, Filter applies a condition to filter rows from a table. Syntax: filter table. Condition table: the table on which you want to apply the filter. Condition: a logical condition Boolean expression that must be met for each row. Only rows where the condition is true are returned. Key features of filter 1. Returns a table. Unlike other filtering functions like all or remove filters, filter returns a table rather than modifying the context of an existing table or column. 2. Can be combined with other functions. Filter is often used in combination with calculate, SUMX, average X, or distinct for more complex queries. 3. Applies row-by-row evaluation. The filter condition is evaluated for each row of the table, allowing granular control over which rows are included in the resulting table. Basic examples. Example 1. Basic filtering. Suppose you have a table called sales with columns sales amount, region, and product category. You want to filter the sales table to return only the rows where the sales amount is greater than 1,000. Filter at sales equal filter sales. Sales amount 1,000. In this case, filter returns a table containing only the rows where sales amount is greater than 1,000. Example 2. Using filter inside calculate. One common use case of filter is inside the calculate function. Suppose you want to calculate the total sales for products in the electronics category where sales are greater than 500. Total electronic sales above 500 equal calculate sum sales amount, filter sales product category equal electronics, and then sales amount 500 here. The filter function filters the sales table to include only rows where the product category is electronics and the sales amount is greater than 500. The calculate function then sums the filtered sales amount values. Example 3. Using filter for distinct calculations, you can also use filter to get unique values under certain conditions. Suppose you want to calculate the number of distinct regions where total sales are greater than 2,000. Distinct regions with ixels equal calculate distinct count sales region, filter sales amount 2,000. In this example, the filter function filters the rows where sales amount is greater than 2,000, and then distinct count counts the unique regions in that filtered result. Combining filter with other functions. Example 4. Filter with SUMX for row-by-row calculations. The filter function can be used with SUMX to perform row-by-row calculations. Suppose you have a sales table with columns quantity and unit price, and you want to calculate the total sales for rows where the sales amount quantity unit price is greater than 500. Total sales above 500 equals SUMX filter sales quantity sales unit price 500, sales quantity. You keep filters. The keep filters function in is used to keep the existing filters in a calculation when used inside calculate, even if new filters are applied. It allows you to maintain filters from the original context rather than replacing them, as typically happens when new filters are applied in calculate. This is particularly useful when you want to add new filter conditions, but still respect the filters already applied in the filter context. Syntax: keep filters expression, a column or table reference, or an expression that is evaluated to create a filter condition. Key features of keep filters. 1. Preserves existing filters. Normally, calculate replaces filters, but keep filters ensures that existing filters are not overwritten and are combined with any new filter conditions. 2. Used with calculate. It is typically used within calculate when modifying or adding to an existing filter context. 3. Combines filters. When new filters are applied along with keep filters, it merges both filters instead of replacing the original context. Basic examples. Example 1. Preserving filters on a column. Suppose you have a table called sales with columns sales amount and region. You want to calculate the total sales for a specific region, but keep any pre-existing filters that might be applied to other columns, for example, product category. Without keep filters, applying a new filter in calculate would replace the existing filters. However, using keep filters ensures that both the existing filter on product category and the new filter on region are respected. Total sales region with category filter equal calculate sum sales amount. Keep filters sales region equal North America. In this case, the keep filters function ensures that any existing filters, for example, on product category, are not removed when the new filter for region is applied. Example 2. Combining multiple filters now. Let's say you want to calculate the total sales for products in the electronics category for the North America region, while keeping any pre-existing filters that might already be applied on other columns. Total sales electronics SINA equal calculate sum sales amount. Keep filters sales product category equal electronics. Keep filters sales region equal North America. Here, keep filters ensures that both the filter on product category and region are added to the existing filter context without replacing other filters already present. Example 3. Keep filters with multiple filter conditions. Suppose you have a more complex scenario where you want to calculate total sales for North America and electronics while keeping other filters intact. And you also want to respect other existing filters like sales date. Total sales multiply conditions equal calculate sum sales amount. Keep filters sales product category equal electronics. Keep filters sales region equal North America. Keep filters year sales date equal 2023. In this example, keep filters ensures that all of the provided conditions are combined with any existing filters. This is particularly useful when the filter context is already complex due to other visuals or slicers in Power BI. Differences between keep filters and regular filters in Calculate without keep filters. When you apply new filters inside Calculate, they typically replace existing filters in the filter context. Total sales replacing filter equal calculate sum sales amount, sales region equal North America. In this example, if there were any other filters applied to the report, such as on product category, they would be replaced by the new filter on region. With keep filters, using keep filters ensures that the new filter on region is added to the existing filters, such as those on product category or sales date. Total sales keeping filters equal calculate sum sales amount, keep filters sales region equal North America. Now, any existing filters on other columns remain active, and both filters are combined. Example 4. Keep filters in complex Power BI scenarios. Keep filters can be extremely useful when creating complex Power BI reports where multiple slicers and filters are applied. For example, if a report contains slicers for product category and region, you can use keep filters to ensure the calculated measure respects the slicer selections while applying additional filter logic. Total sales with slicer respect equal calculate sum sales amount. Keep filters sales product category equal electronics. Keep filters sales region equal North America. This would ensure that the slicers on product category and region are respected in the calculation, without removing any slicer-based filters. Summary: the keep filters function allows you to maintain existing filters in a calculation when new filters are applied, ensuring that the original filter context is not overwritten. It is primarily used inside Calculate to combine new filters with those already in place. This makes it extremely useful in scenarios where multiple filters or slicers are being used in Power BI reports, allowing for more granular control over how filters are applied. You remove filters. The remove filters function is used to explicitly clear filters from a column or a table. Unlike all, which both removes filters and returns all rows from a table or column, remove filters is a more intuitive and direct way of simply removing filters that have been applied to a calculation. This function is particularly useful when you want to ignore any filters applied by slicers or report visuals in Power BI. Syntax: remove filters, table, remove filters, column 1, column 2. Table removes filters from the entire table. Column removes filters from a specific column. Column 1, column 2 removes filters from multiple columns. Key features of remove filters: 1. Removes filters without returning all rows. Unlike all, which can also return all rows, remove filters simply clears any filters without modifying the table structure. 2. Used in Calculate. It is typically used within Calculate to control or reset the filters for a specific calculation. 3. Removes user or slicer applied filters. Remove filters is particularly useful in Power BI when you want to remove filters applied by slicers or other report visuals without impacting other calculations. Basic examples. Example 1. Removing filters from a single column. Assume you have a sales table with columns sales amount, product category, and region. You want to calculate total sales while ignoring any filters applied on the region column. Total sales ignore region equal calculate sum sales amount. Remove filters sales region. This formula removes any filter applied to the region column, ensuring that the total sales are calculated across all regions, regardless of the current filter context. Example 2. Removing filters from multiple columns. If you want to ignore filters on both product category and region, you can remove filters from multiple columns. Total sales ignore category and region equal calculate sum sales amount. Remove filters sales product category, sales region. This removes filters from both the product category and region columns. So the total sales calculation includes all products and all regions. Example 3. Removing filters from the entire table. In some cases, you may want to remove all filters from the sales table to calculate the total sales without any filtering. Total sales all equal calculate sum sales amount. Remove filters sales here. Remove filters sales clears. All filters applied to the sales table, ensuring the total sales calculation includes all rows. Example 4. Removing filters from a visual slicer in Power BI. Suppose you have a slicer in Power BI that allows the user to filter by product category. However, you want to create a measure that calculates total sales, ignoring any filters applied by the slicer. Total sales ignore category slicer equal calculate sum sales amount. Remove filters sales product category. In this case, even if the user selects specific categories in the slicer, the measure will return the total sales for all product categories. Example 5. Using remove filters to calculate percentages. You can use remove filters to calculate percentages. For instance, calculating the percentage of sales for a specific region compared to total sales across all regions can be done by removing the region filter in the denominator. Sales preceding North America equal divide sum sales amount. Calculate sum sales amount. Remove filters sales region. This formula calculates the percentage of sales for North America by dividing the sales for that region by the total sales across all regions. Comparison. Remove filters versus all. While both remove filters and all can be used to remove filters in a calculation, they have subtle differences. All removes filters and also returns all rows from a table or column. It can be used to ignore relationships as well. Example. Total sales all equal calculate sum sales amount. All sales region remove filters. Removes filters but doesn't return all rows like all does. It is more focused on clearing filters rather than manipulating the table structure. Example. Total sales ignore filters equal calculate sum sales amount. Remove filters sales region use cases use case 1. Ignoring slicers in Power BI. Remove filters is often used when you need to create measures that ignore slicer selections. For example, if a slicer filters the report by region, but you need to calculate total sales for all regions regardless of the slicer, you can use remove filters. Use case 2. Showing overall totals in certain scenarios. You may want to calculate both filtered and unfiltered totals for comparison. For example, showing the sales for a particular category alongside total sales for all categories, regardless of filters applied in the report. Total sales overall equal calculate sum sales amount. Remove filters sales product category use case 3. Percentage calculations. In many business scenarios, you need to calculate percentages where the denominator should include the total unfiltered value, while the numerator reflects a filtered subset of data. Remove filters is ideal for such calculations, as it can ignore filters applied to the denominator. Summary. The remove filters function is used to explicitly remove filters from columns or tables in your calculations. It allows for more controlled and focused filtering behavior compared to all, making it especially useful when you want to clear slicer filters or ignore certain filter contexts. Remove filters is particularly powerful in Power BI when working with dynamic filters in visuals, ensuring that certain measures respect or ignore specific filter conditions based on your reporting needs. Use same period last year. The same period last year function in is used to return a set of dates that represent the same period in the previous year. This function is particularly useful for comparing performance metrics such as sales, revenue, or any other measure from the same period in the previous year. It is typically used in time intelligence calculations to analyze trends over time, such as year-over-year comparisons. Syntax: same period last year, dates. A column that contains dates. This must be a column from a date table or a time intelligence function that returns a set of dates. Key features of same period last year: 1. Returns a date range. The function returns a set of dates corresponding to the same period in the previous year. 2. Handles different time intervals. The function works for any time period, such as days, months, quarters, or years, as long as the dates parameter contains valid date values. 3. Useful in time intelligence. It allows easy year-over-year comparisons and is often used with measures like sum, count, or average to compare results from the current year to the previous year. How same period last year works: if you pass a day, it returns the same day in the previous year. If you pass a month, it returns the entire month from the previous year. If you pass a quarter, it returns the same quarter from the previous year. Example 1. Year-over-year sales comparison. Suppose you have a sales table with columns sales amount and sales date, and a separate date table that includes a date column. You can create a measure to calculate sales for the same period in the previous year. Sales last year equal calculate sum sales amount. Same period last year date. This measure calculates the total sales for the same period last year. For example, if you filter the report for May 2024, this measure would return sales for May 2023. Example 2. Year-over-year comparison at different time periods. If you want to compare the total sales for the entire year or by quarter, same period last year adapts to the context in which it's used. For example, if you visualize sales by month, the function will return the total sales for the same month in the previous year. Sales comparison last year equal calculate sum sales amount. Same period last year date. When placed in a visual that shows sales by month, this measure compares each month to the same month in the prior year. Example 3. Year-over-year growth. You can also use same period last year to calculate year-over-year growth by comparing sales in the current year with the previous year. YoY growth equal divides sum sales amount. Sales last year. In this case, sales last year is calculated using same period last year, and the year-over-year growth is calculated by dividing the difference between current and previous year sales by the sales of the previous year. Example 4. Same period last year with date filters. Let's say you are using a slicer for months, and you use total YTD. The total YTD function in is used to calculate a year-to-date YTD total of an expression, such as a sum of sales, starting from the beginning of the year to the current period. It's a key function in time intelligence, making it easy to aggregate data over a year-to-date period based on a specific date column. Syntax: total YTD expression. Dates, filter, year-end date expression. The calculation you want to aggregate, such as sum, count, etc. Dates: a column that contains date values, usually from a date table. Filter optional. Additional filter expressions to apply. Year-end date optional. Specifies a custom fiscal year-end date, other than the default December 31. Key features of total YTD. 1. Calculates year-to-date totals. It sums or aggregates values from the start of the year until the current date within the context. 2. Supports fiscal years. You can customize the year-end date to handle fiscal years that don't end on December 31. 3. Works with filters. It can apply additional filters while calculating YTD totals, making it flexible in different reporting scenarios. Example 1. Basic year-to-date sales calculation. Suppose you have a sales table with columns, sales amount, and sales date. You can create a YTD measure to calculate the total sales for the current year up to the current period. Total sales YTD equal total YTD sum sales amount. Date. This measure will calculate the sum of sales amount from the start of the year to the current date, based on the date column. If you visualize this measure by month, it will show the cumulative sales month to month until the current month in the year. Example 2. Year-to-date calculation with a fiscal year. If your fiscal year ends on a different date, say June 30, you can specify a custom year-end date in the total YTD function. Total sales fiscal YTD equal total YTD sum sales amount, date, all sales, 0630. In this example, the YTD calculation starts from the fiscal year beginning on July 1 and ends on June 30. This is useful for businesses or organizations that don't operate on a calendar year. Example 3. Applying filters with total YTD. You can add a filter to the total YTD function to calculate a YTD total for a specific region or product category. For instance, to calculate YTD sales for the North America region, total sales YTD North America equal total YTD sum sales amount, date, sales region equal North America. This measure calculates the YTD sales, but only for the North America region by adding a filter condition to the total YTD function. Example 4. YTD growth comparison. You can compare the YTD sales of the current year to the YTD sales of the previous year using total YTD and same period last year. Sales YTD current year equal total YTD sum sales amount. Date sales YTD last year equal total YTD sum sales amount. Same period last year, date YTD growth equal divide sales YTD current year. Sales YTD last year, sales YTD last year. This calculation returns the YTD sales growth by comparing the current year to the previous year. Example 5. Using total YTD in a Power BI visual. If you use total MTD, the total MTD function is used to calculate the month-to-date total for a measure or expression. This is especially useful in scenarios where you want to track cumulative metrics like sales, revenue, or expenses from the beginning of the month up to a specific date. Syntax: total MTD expression, dates, filter expression. The expression or calculation you want to aggregate, like sum sales amount. Dates: a column containing date values, usually from a date table. Filter: optional, a filter expression that modifies the filter context. Key features of total MTD. 1. Month-to-date calculation. It aggregates data from the start of the current month up to the date currently in context. 2. Handles dynamic date contexts. The function adapts to the current date context, making it useful for dashboards that update automatically based on current date ranges. 3. Filter flexibility. You can use an optional filter to modify or refine the results based on additional conditions. Example 1. Month-to-date sales. Suppose you have a sales table with sales amount and sales date columns, and a separate date table with a date column. You can calculate the total sales for the current month up to the current date using total MTD. Sales MTD equal total MTD sum sales amount. Date. This measure calculates the total sales from the beginning of the month to the current date based on the filter context in your report. For example, if today's date is the 15th of the month, this will return the total sales from the 1st to the 15th. Example 2. Month-to-date sales with filters. You can further refine the total MTD calculation by adding a filter. For example, you can calculate month-to-date sales for a specific region, such as North America. Sales MTD equal total MTD sum sales amount, date, sales region equal North America. This measure calculates the month-to-date sales for the North America region, while ignoring sales from other regions. Example 3. Month-to-date with different aggregations. The total MTD function works with any aggregation, not just some. You can use it for averages, counts, or custom calculations. For instance, you can calculate the month-to-date number of orders using count rows. Orders MTD equal total MTD count rows sales, date. This measure counts the total number of orders placed from the beginning of the month up to the current date. Example 4. Cumulative month-to-date with running total. You can use total MTD to create a running total visualization. When used in combination with a line chart or other time-based visual, it displays the cumulative total over time for each day of the month. Cumulative sales MTD equal total MTD sum sales amount, date in a line chart. This would show the cumulative sales day by day, from the start of the month to the current date. Example 5. Month-to-date growth. You can calculate month-to-date growth by comparing the total MTD of the current month with the previous month. For instance, if you have a measure for sales growth, you can calculate growth using a formula like this. MTD sales growth equal divide sales MTD sales prevent MTD sales prevent MTD. This formula calculates the percentage growth between the month-to-date sales of the current month and the same period in the previous month. Example 6. Total MTD in Power BI visuals in Power BI. Total MTD can be used with date slicers or visuals to provide dynamic, real-time month-to-date figures based on user selections. For example, if you add a slicer for months, the total MTD measure will dynamically adjust to show the cumulative total for the selected month up to the last day in the filter context. Use cases. Use case 1. Financial reports. In financial reporting, you might want to show month-to-date revenue or expenses, allowing you to track performance within the current month. Use case 2. Sales dashboards. Sales teams often monitor month-to-date performance to see how they're tracking toward monthly targets. Total QTD. The total QTD function is used to calculate a quarter-to-date QTD total of an expression, such as the sum of sales, starting from the first day of the current quarter up to the current period. It is another essential function for time intelligence, often used to track quarterly performance metrics. Syntax. Total QTD expression, dates, filter expression. The calculation you want to aggregate, such as sum, count, etc. Dates. A column that contains date values, usually from a date table. Filter optional. Additional filter expressions to apply. Key features of Total QTD1. Calculates quarter-to-date totals. It sums or aggregates values starting from the first day of the quarter to the current date within that quarter. 2. Works with filters. You can apply additional filters to calculate QTD values for specific categories, regions, or products. 3. Respects calendar quarters. The function automatically follows standard calendar quarters Q1, Jan-Mar, Q2, April-June, etc. Example 1. Basic quarter-to-date sales calculation. Suppose you have a sales table with columns sales amount and sales date. You want to calculate the total sales for the current quarter up to the current period. Total sales QTD equal total QTD sum sales amount, date. This measure will calculate the sum of sales amount from the start of the current quarter to the current date, based on the date column. If you visualize this measure by month, it will show the cumulative sales within the current quarter. Example 2. Quarter-to-date calculation with a filter. You can apply additional filters to calculate the QTD total for specific product categories or regions. For example, calculating QTD sales for the electronics category. Total sales QTD electronics equal total QTD sum sales amount, date, sales product category equal electronics. This measure will calculate the QTD sales, but only for the rows where the product category is electronics. Example 3. Using total QTD with multiple filters, you can combine total QTD with other conditions. For instance, calculating QTD sales for the North America region for the electronics category. Total sales QTD na electronics equal total QTD sum sales amount date sales region equal North America and sales product category equal electronics. This measure aggregates the sales from the start of the quarter up to the current period, but only for products in the electronics category sold in the North America region. Example 4. Quarter-to-date growth comparison. You can compare the current QTD performance with the previous year's QTD performance using same period last year. Sales QTD current year equal total QTD sum sales amount date sales QT. The last year equal total QTD sum sales amount same period last year date YOI QTD growth equal divide sales QTD current year sales QTD last year sales QTD last year. In this example, you are calculating the current QTD sales and comparing them with the QTD sales of the same quarter in the previous year to determine year-over-year growth. Example 5. Visualizing total QTD in Power BI. In Power BI, you can use the total QTD function in a visual such as a line chart or bar chart to display the cumulative sales by month within each quarter. The total QTD function will automatically reset the cumulative total at the start of each new quarter. Total sales QTD equal total QTD sum sales amount date. When placed in a chart showing sales by month, it will display cumulative sales within the quarter and restart at the beginning of the next quarter. Summary: the total QTD function is a powerful tool for calculating cumulative totals within a quarter. It is particularly useful in quarterly reporting and helps track performance from the start of a quarter up to the current period. By applying filters and combining it with other functions like same period last year, you can perform detailed quarter-to-date comparisons and growth analyses. The date add function is a time intelligence function that shifts a set of dates by a specified number of intervals days, months, quarters, or years. It's useful for scenarios where you need to calculate measures that compare data across different time periods, such as comparing this year's sales with the sales from the same period last year or last month. Syntax: date add dates, number of intervals, interval dates. A column containing date values, typically from a date table. Number of intervals. The number of intervals to shift the dates positive to move forward, negative to move backward. Interval. The type of interval to apply. The options are day, shift by days, month, shift by months, quarter, shift by quarters, year, shift by years. Key features of date add 1. Shifts dates forward or backward. You can use it to shift dates by a specific number of intervals, days, months, quarters, or years. 2. Useful in time intelligence. Commonly used to compare performance across different periods, for example, month over month, year over year. 3. Combines with aggregation functions. You can combine date add with functions like calculate to compute measures over shifted periods. Example 1. Shifting dates by 1 year. Suppose you have a sales table with a sales amount column and a date table. You can use date add to shift the dates back by 1 year to calculate sales from the same period in the previous year. Sales last year equal calculate sum sales amount date add date 1 year. In this example, date add shifts the dates in the date column back by 1 year, and the calculate function sums the sales for the shifted date range. This is useful for year-over-year comparisons. Example 2. Shifting dates by 1 month. You can also use date add to compare data from the previous month. For example, calculating the total sales for the previous month. Sales last month equal calculate sum sales amount date add date 1 month. This shifts the dates back by 1 month and calculates the total sales for that previous month. Example 3. Shifting dates by a quarter. If you want to compare sales between the current quarter and the previous quarter, you can shift the dates by 1 quarter using date add. Sales last quarter equal calculate sum sales amount Date add date date 1. Quarter. This shifts the date range back by 1 quarter and calculates the total sales for the previous quarter. Example 4. Custom period comparison. Multiple years back, you can shift the dates by multiple intervals. For example, if you want to calculate the sales from 2 years ago, you can shift the dates back by 2 years. Sales 2 years ago equal calculate sum sales amount, date add date date 2 year. This calculates the sales for the same period 2 years ago, which is useful for multi-year comparisons. Example 5. Shifting dates forward. You can also use date add to shift dates forward. For example, calculating expected sales for the same period next month. Sales next month equal calculate sum sales amount, date add date date 1 month. This shifts the date range forward by 1 month and calculates the total sales for the next month. Example 6. Combining date add with other time intelligence functions. You can combine date add with other time intelligence functions to perform more complex analyses. For example, if you want to compare the year-over-year growth by shifting the date back 1 year and calculating the percentage change. YOI growth equal divide sum sales amount. Calculate sum sales amount, date add date date 1 year. Calculate sum sales amount, date add date date 1 year. This formula calculates the year-over-year growth by comparing the current period's sales with the same period last year. Use cases. Use case 1. Year-over-year and month-over-month comparisons. Date add is particularly useful for comparing performance over time, such as comparing current month sales to the previous month or the same month last year. Use case 2. Dynamic date shifting in Power BI. In Power BI, you can use date add to create measures that dynamically shift based on the date context of the report. This allows users to interact with reports and see how performance changes across different periods. Use case 3. Forecasting and planning by shifting dates forward. You can use date add to forecast sales or other metrics for future periods based on historical trends. Summary. The date add function is a powerful tool for time intelligence, allowing you to shift dates by specific intervals, days, months, quarters, or years. It is commonly used to compare data from different periods, such as year-over-year or month-over-month comparisons. When combined with calculate, it provides an easy way to aggregate values over shifted time ranges, making it essential for time-based reporting and analysis in Power BI and other enabled dates between date add function. In the date add function is used to shift a set of dates by a specified interval such as days, months, quarters, or years. It's particularly useful for time-based calculations where you want to move backward or forward by a certain number of periods. Syntax. Date add dates, number of intervals, interval dates. A column containing date values. Number of intervals. A positive or negative integer to specify how many intervals to shift. Positive moves forward, negative moves backward. Interval. The unit of time to shift by. Possible values are day, month, quarter, or year. Key features. 1. Shifts dates by a specified interval. You can move the date context forward or backward by a number of days, months, quarters, or years. 2. Supports various time periods. It allows you to shift dates based on day, month, quarter, or year intervals, making it highly flexible for time-based calculations. 3. Can be used in time intelligence. It's commonly used to compare current periods with previous or future periods. Example 1. Shift by 1 year back. Suppose you have a sales table with sales date and sales amount. You want to calculate the total sales from the same period last year. Sales last year equal calculate sum sales amount, date add date date 1 year. In this example, date add date date 1 year shifts the date context 1 year back, allowing you to calculate last year's sales for the same time period. Example 2. Shift by 1 month forward to calculate the sales for the next month. You can shift the date context forward by 1 month. Sales next month equal calculate sum sales sales amount. Date add date date 1 month. This shifts the date context 1 month forward and calculates the total sales for the next month based on the current filter context. Example 3. Quarter-to-quarter comparison. You can use date add to compare the current quarter's sales to the previous quarter's sales by shifting the date context back by 1 quarter. Sales previous quarter equal calculate sum sales sales amount. Date add date date 1 quarter. This measure returns the sales from the previous quarter. Dates between function in the dates between function in is used to return a set of dates between a specified start and end date. It's useful when you need to filter data to only include a specific date range. Syntax: dates between dates, start date, end date dates. A column containing date values. Start date, the beginning of the date range. End date, the end of the date range. Key features: 1. Returns a range of dates. It retrieves a range of dates between the specified start and end dates. 2. Ideal for custom date filters. When standard time intelligence functions like total YTD, same period last year don't meet your needs, dates between allows you to define your own date ranges. 3. Supports dynamic calculations. By using measures or expressions for the start and end dates, you can make the range dynamic and adjust based on slicer selections or other contexts. Example 1. Sales between two specific dates. Suppose you want to calculate the total sales between January 1st, 2023 and March 31st, 2023. Sales Q1 2023 equal calculate sum sales sales amount. Dates between date 2023 1 date 2023 3/31. This returns the total sales between the specified date range. Example 2. Dynamic date range. You can also make the start and end dates dynamic using measures. For instance, calculating the total sales for the last 30 days from today. Sales last 30 days equal calculate sum sales sales amount. Dates between date today 30. Today in this example, today provides the current date, and today 30 dynamically calculates the start date, giving the sales for the last 30 days. Example 3. Custom fiscal quarter calculation. If your fiscal quarter does not align with the calendar quarter, you can use dates between to calculate custom ranges. For example, for a fiscal quarter starting on February 1, sales fiscal 1 equal calculate sum sales sales amount. Dates between date 2023 2 1, date 2023 4 30. This returns the total sales for the custom fiscal quarter. Summary date add shifts dates forward or backward by days, months, quarters, or years, and is commonly used for time-based comparisons. Dates between retrieves a custom date range and is flexible for calculating metrics over specific time periods. Both functions are critical for advanced time intelligence calculations in allowing for precise control over date-based filtering and comparisons. Dates in period. The dates in period function returns a table containing a set of dates from a specified period. You provide a starting date and a time interval in days, months, quarters, or years, and the function generates the set of dates that fall within that period. This function is highly useful for time intelligence calculations such as rolling averages, running totals, or comparing data over a custom date range. Syntax: dates in period dates, start date, number of intervals, interval dates. A column that contains date values typically from a date table. Start date, the starting date for the calculation. This is usually a single date value. Number of intervals, the number of intervals to move backward negative value or forward positive value from the start date. Interval, the type of interval to use, such as day, month, quarter, year. Key features of dates in period. 1. Returns a dynamic range of dates. It calculates a custom date range based on the number of intervals and interval type. 2. Handles moving date windows. This function is ideal for calculating running totals or moving averages. as it can define a rolling period, for example, the last 12 months or the last 30 days. 3. Works with Calculate. It is often used inside Calculate to modify the filter context and aggregate data over a specific period. Example 1. Sales in the last 30 days. Suppose you have a sales table with columns sales amount and sales date, and a date table. You want to calculate total sales for the last 30 days from today. Sales last 30 days equal calculate sum sales sales amount. Dates in period date today 30 day. In this example, dates in period date today 30 day generates the set of dates from today going back 30 days. The calculate function then sums the sales over that date range. Example 2. Sales in the last 12 months. You can also use dates in period to calculate sales for the past 12 months. This is useful for rolling year-over-year comparisons. Sales last 12 months equal calculate sum sales sales amount. Dates in period date today 12 month here. Dates in period generates the set of dates for the last 12 months, and the total sales for that period are calculated. Example 3. Rolling quarterly sales. If you want to calculate the total sales for the past 4 quarters, you can use dates in period with the quarter interval. Sales last 4 quarters equal calculate sum sales sales amount. Dates in period date today 4 quarter. This measure sums the sales over the last 4 quarters, giving you a rolling quarterly total. Example 4. Sales for the next 6 months. Dates in period can also be used to calculate future periods. For instance, if you want to calculate forecasted sales for the next 6 months, you can use a positive value for the number of intervals. Sales next 6 months equal calculate sum sales sales amount. Dates in period date today 6 month. This measure calculates the total sales for the next 6 months from today, making it useful for forecast analysis. Example 5. Year-to-date sales using DU dates MTD. The dates MTD function returns a table of dates from the beginning of the current month to the last date in the filter context. This is typically used in month-to-date MTD calculations, where you want to compute values like sales or revenue for the current month up to the current day. Syntax dates MTD dates. A column that contains date values usually from a date table. Key features of dates MTD1. Returns the month-to-date dates. It generates a set of dates from the first day of the current month to the last date in the current filter context. 2. Used for time intelligence. It simplifies month-to-date MTD calculations for tracking cumulative metrics within a month. 3. Often used with Calculate. It works best when used in combination with functions like Calculate to aggregate values over the MTD period. Example 1. Month-to-date sales. Assume you have a sales table with sales amount and sales date columns, and you want to calculate the month-to-date sales. Here's how you can use the dates MTD function. Sales MTD equal calculate sum sales sales amount. Dates MTD date. This measure calculates the total sales from the start of the current month up to the current day, based on the dates provided in the date column. Example 2. Month-to-date orders. You can use dates MTD with other aggregation functions, like count rows, to calculate month-to-date metrics for different business measures. For example, calculating the number of orders for the current month. Orders MTD equal calculate count rows sales. Dates MTD date. This measure counts the total number of orders placed from the first day of the month to the current date. Example 3. Month-to-date revenue with filters. You can apply additional filters within Calculate to get month-to-date calculations for specific categories, regions, or products. For example, to calculate MTD revenue for the electronics product category. Revenue MTD electronics equal calculate sum sales revenue. Dates MTD date. Sales product category equal electronics. This measure calculates the month-to-date revenue for the electronics category, ignoring sales from other categories. Example 4. Rolling MTD with dates MTD in Power BI. You can visualize MTD trends in Power BI by creating a line chart that shows cumulative MTD values day by day. When you use dates MTD in a visual context, the calculation updates dynamically as the date range changes. Cumulative sales MTD equal calculates sum sales amount, dates MTD date. This will give you a cumulative month-to-date sales total, which resets at the beginning of each month. Example 5. Using dates MTD with non-standard date ranges, while dates MTD works with standard calendar months. If you are working with non-standard fiscal months or custom date ranges, you might need to adjust the context using other functions. However, for calendar-based month-to-date calculations, dates MTD is efficient and easy to use. Use cases. Use case 1. Financial reporting. In financial reports, it is common to track month-to-date sales, revenue, or expenses to monitor how the business is performing relative to monthly goals or targets. Dates MTD simplifies these calculations by returning only the relevant dates. Use case 2. Sales dashboards. Sales teams often want to see how they're performing within the current month. Using dates MTD in sales dashboards can provide a real-time view of month-to-date performance, which helps teams assess progress toward monthly quotas. Use case 3. Cumulative measures. You can use dates MTD to create running totals within a month, showing how a key metric, like sales, accumulates over time. This helps to visualize trends and patterns as the month progresses. Summary. The dates MTD function is a powerful tool for performing month-to-date MTD calculations. It returns a set of dates starting from the first day of the month to the current date in the filter context, making it ideal for tracking cumulative metrics like sales, revenue, or orders within a month. By using it with Calculate, you can easily perform MTD calculations and incorporate additional filters for more precise reporting. Use dates QTD. The dates QTD function is used to return a table containing a set of dates starting from the first day of the current quarter up to the last date in the filter context. It is particularly useful for quarter-to-date QTD calculations, where you want to compute cumulative metrics like sales, revenue, or expenses from the start of the current quarter to a specific date. Syntax. Dates QTD dates. A column that contains date values typically from a date table. Key features of dates QTD1. Returns quarter-to-date dates. It provides a set of dates starting from the first day of the current quarter up to the current date. 2. Used for time intelligence. It simplifies quarter-to-date QTD calculations to track cumulative metrics within a quarter. 3. Works with Calculate. It is commonly used within the Calculate function to aggregate values over the QTD period. Example 1. Quarter-to-date sales. Suppose you have a sales table with sales amount and sales date columns and a date table. You want to calculate the total sales for the current quarter up to the current date. Sales QTD equal calculate sum sales amount, dates QTD date. This measure calculates the total sales from the start of the current quarter up to the current date based on the dates in the date column. Example 2. Quarter-to-date orders. You can use dates QTD with other aggregation functions to compute various metrics. For example, calculating the number of orders received in the current quarter. Orders QTD equal calculate count rows sales, dates QTD date. This measure counts the total number of orders placed from the beginning of the current quarter to the current date. Example 3. Quarter-to-date sales with filters. You can apply additional filters to the dates QTD calculation to analyze QTD values for specific categories or regions. For example, calculating quarter-to-date sales for the North America region. Sales QTD not equal calculate sum sales amount, dates QTD date. Sales region equal North America. This measure computes the quarter-to-date sales for the North America region, ignoring sales from other regions. Example 4. Rolling QTD sales. You can create a rolling QTD measure that will reset at the beginning of each new quarter, showing how sales accumulate over time during the quarter. Cumulative sales QTD equal calculate sum sales amount, dates. QTD date. This measure can be visualized in Power BI using a line or bar chart to show cumulative sales within the quarter. Example 5. Comparing QTD performance, you can compare current quarter-to-date performance with the same quarter last year by combining dates QTD with same period last year. For example, to calculate the QTD sales from the previous year, sales QTD last year equal calculate sum sales amount, dates QTD same period last year date. This measure calculates the total sales for the same quarter in the previous year, which can be used to compare performance year over year. Use cases. Use case 1. Financial reporting. In financial reporting, you might need to show quarter-to-date totals for revenue, expenses, or profit. The dates QTD end of month. The end of month function returns the last date of the month in the current filter context. It is particularly useful in scenarios where you need to aggregate data up to the last day of a month or perform end-of-month calculations like closing balances, month-end sales, or inventory counts. Syntax. End-of-month dates. A column that contains date values, typically from a date table. Key features of end-of-month 1. Returns the last day of the month. It gives you the last date of the month based on the date context, which can be useful for month-end reporting. 2. Works in time intelligence calculations, commonly used with functions like calculate to compute month-end measures or aggregates. 3. Handles dynamic date ranges, automatically adjusts to the filter context, whether you are looking at individual days, weeks, or months. Example 1. Last day of the current month. Assume you have a date table with a date column. To calculate the last day of the current month, last day of month equal end of month date. This will return the last date of the month based on the current filter context. If the report or visual is filtered for January 2024, the result will be January 31st, 2024. Example 2. Month-end sales. You can calculate the total sales up to the last day of the month using the end-of-month function inside Calculate. For instance, if you have a sales table with sales amount and sales date columns, you can calculate the sales for the last day of the month like this. Sales end of month equal calculate sum sales amount, end of month date. This measure calculates the total sales on the last day of the month in the current filter context. Example 3. Month-end inventory balance. Suppose you want to calculate the inventory balance at the end of each month. If you have an inventory table with columns inventory balance and inventory date, you can calculate the closing balance using end of month. Inventory end of month equal calculate sum inventory balance, end of month date. This measure gives the total inventory balance as of the last day of the month. Example 4. Last date of a custom period. You can combine end of month with other functions like dates between to calculate values for custom periods ending on the last day of a month. For example, if you want to calculate the total sales for the last 6 months ending at the last day of the current month, sales last 6 months end of month equal calculate sum sales amount, dates between date, end of month date 180, end of month date. This formula calculates the total sales for the last 6 months up to the end of the current month. Use cases. Use case 1. Financial reporting. In financial reports, end of month is helpful for calculating end of month values like account balances, liabilities, or profit. It ensures that your calculations are accurate as of the last day of each month. Use case 2. Sales and inventory reports for companies that track sales or inventory. End of month is essential for calculating closing balances, month-end sales, or stock levels. It allows businesses to get an accurate picture of their position at the end of each month. Use case 3. Month-end comparison. You can use end of month to compare metrics at the end of different months or perform month-over-month comparisons. Summary. The end-of-month function is a key tool for performing month-end calculations. It returns the last date of the month based on the current filter context, making it particularly useful for financial and inventory reporting where month-end values are crucial. By combining it with other functions like calculate or dates between, you can perform complex end-of-month analysis for different business metrics. End of quarter, endofire. The endofire function returns the last date of the year in the current filter context for a given column of dates. It is a time intelligence function, commonly used to calculate totals or other measures as of the end of the year. Syntax endofire dates, year-end date dates. A column containing date values typically from a date table. Year-end date optional. A custom year-end date used for fiscal years. If omitted, the default is December 31. Key features of endofire 1. Returns the last date of the year. It identifies the last date in the year based on the filter context or the custom year-end date if specified. 2. Handles both calendar and fiscal years. You can specify a custom year and date, making it flexible for fiscal year reporting. 3. Useful in time intelligence calculations. It is often used in combination with other functions like calculate to calculate end-of-year totals or perform year-end comparisons. Example 1. Get the last date of the year. Suppose you have a date table and you want to return the last date of the year based on the current filter context. Endofire date equal endofire date date. This returns the last date of the year, which is typically December 31, depending on the filter context. Example 2. Calculate year-end sales. You can use endofire in combination with calculate to find total sales as of the end of the year. Suppose you have a sales table with sales amount and sales date. Sales endofire equal calculate sum sales amount, date equal endofire date date. This calculates the total sales on the last day of the year, December 31. Example 3. Fiscal year-end calculation. If your fiscal year ends on a date other than December 31, you can specify a custom year-end date. For example, if your fiscal year ends on June 30, fiscal year-end date equal endofire date 0630. This returns the last date of the fiscal year June 30 based on the date table. Example 4. Comparing year-end performance. You can use endofire to compare performance at the end of the current year versus the end of the previous year. For example, calculating year-end sales for both the current and previous years. Sales end of current year equal calculate sum sales amount. Date equal endofire date sales end of last year equal calculate sum sales amount. Date equal endofire same period last year date. This calculates total sales as of the last date in the current and previous years, allowing you to compare performance year over year. Use cases. Use case 1. Year-end financial reporting. In financial reporting, it's common to calculate year-end totals for various metrics such as revenue, profit, or expenses. The endofire function helps generate these totals by pinpointing the last day of the year. Use case 2. Fiscal year reporting. For businesses with a fiscal year that does not end on December 31, you can use endofire with a custom fiscal year end date to calculate metrics as of the end of the fiscal year. Use case 3. Year-end performance comparisons. By combining endofire with other time intelligence functions, such as same period last year, you can easily compare end-of-year performance across multiple years. Summary. The endofire function returns the last date of the year for a given column of dates, making it a key tool for year-end calculations and comparisons. You can also customize the year-end date for businesses operating on a fiscal year, making this function versatile for both calendar and fiscal reporting needs. It is commonly used for year-end sales, revenue, or performance comparisons in dashboards and reports. First date. The first date function returns the first earliest date in the current filter context for a given column of dates. This is useful for time intelligence calculations where you need to identify the starting point of a period, such as the first date of a month, quarter, or year. Syntax. First date dates. A column that contains date values typically from a date table. Key features of first date 1. Returns the earliest date. It provides the first date within the current filter context, such as the earliest date in a month, quarter, or year. 2. Works with time intelligence. It's frequently used in time-based calculations, such as calculating metrics from the beginning of a period. 3. Interacts with calculate. It is often used with calculate to modify the context and compute values starting from the first date. Example 1. Get the first date in the current filter context. Suppose you have a date table, and you want to find the first date within the current filter context, such as the first day of the month. First date in context equal first date date date. This will return the earliest date based on the current context, for example, the first date of the currently filtered month. Example 2. Calculate sales on the first day of the period. If you have a sales table with sales amount and sales date, and you want to calculate sales for the first day of the current period, you can use first date with calculate. Sales first date equal calculate. Sum sales sales amount. Date date equal first date date date. This calculates the total sales that occurred on the first date in the current filter context, for example, the first day of the month or quarter. Example 3. First date of a fiscal year. You can combine first date with other time intelligence functions to compute the first date of a fiscal year. For example, if you want to find the first date of the fiscal year starting on July 1, first date fiscal year equal calculate first date date date, dates YTD date date, 0630. This finds the first date in the fiscal year, which begins on July 1. Example 4. Comparing first dates between years. You can use first date to compare metric starting from the first date of the current year with the same period in the previous year. For instance, comparing sales on the first day of this year with the first day of last year. Sales first day current year equal calculate sum sales sales amount. Date date equal first date 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 sales first day last year equal calculate sum sales sales amount. Date date equal first date same period last year date date. This will give you the sales on the first date of both the current last date. The last date function in returns the last most recent date in the current filter context for a given column of dates. It's a useful function for time intelligence calculations where you need to identify the endpoint of a period, such as the last date in a month, quarter, or year. Syntax last date dates dates. A column that contains date values usually from a date table. Key features of last date 1. Returns the latest date. It provides the last date within the current filter context, which can be the end of a month, quarter, or year. 2. Works with time intelligence. Commonly used in time-based calculations, such as year-end totals, rolling averages, or month-end metrics. 3. Interacts with calculate. Often used in conjunction with calculate to compute values for the last date in the current context. Example 1. Get the last date in the current filter context. Suppose you have a date table and you want to return the last date within the current filter context, for example, the last day of the month or year. Last date in context equal last date date date. This returns the latest date based on the current filter context, such as the last date of a selected month or quarter. Example 2. Calculate sales on the last day of a period. If you have a sales table with sales amount and sales date, and you want to calculate the total sales for the last day of the current filter context, you can use last date along with calculate. Sales last date equal calculate sum sales sales amount. Date date equal last date date date. This will calculate the total sales that occurred on the last date in the current filter context, such as the last day of the month or quarter. Example 3. Last date of the fiscal year. You can combine last date with other time intelligence functions to calculate the last date of a fiscal year. For instance, if your fiscal year ends on June 30, you can calculate the last date of the fiscal year. Last date fiscal year equal calculate last date date date. Dates YTD date date, 0630. This returns the last date of the fiscal year based on a June 30 year end. Example 4. Comparing last dates between years. You can use last date to compare metrics between the last date of the current year and the same date in the previous year. For example, comparing sales on the last day of this year with the last day of the previous year. Sales last day, current year equal calculate sum sales sales amount. Date date equal last date 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 sales last day last year equal calculate sum sales sales amount. Date date equal Last date, same period, last year date. This calculates the total sales on the last date of the current year and compares it with the last date of the previous year. Use cases. Use case 1. Month-end or year-end reporting. Last date is often used to calculate month-end or year-end totals for key metrics like revenue, profit, or sales. It allows you to identify the last date of the reporting period and compute totals for that date. Use case 2. Rolling totals. In scenarios where you need to calculate rolling totals, such as a 12-month rolling total, you can use last date to define the endpoint of the period. Use case 3. Financial metrics. For financial metrics, such as balance sheets, which are typically calculated at the end of a period, last date helps in finding the last date to retrieve closing balances or similar metrics. Summary. The last date function in is an essential time intelligence function that returns the last date in a given filter context. It's useful for calculating metrics based on the most recent date within a period, such as month-end, quarter-end, or year-end values. It is commonly used in combination with other functions like calculate to compute cumulative totals, compare last dates across years, or analyze trends at the end of periods. U first non-blank value. The first non-blank value function returns the first value in a column that is not blank based on the evaluation of an expression. It is typically used to retrieve meaningful data from a column where some rows may be blank or null. This function is helpful when you want to return the first valid entry in a column or when working with sparse data. Syntax. First non-blank value column, expression column, a column that contains the values you want to evaluate. Expression, an expression or calculation that is evaluated over the column. Key features of first non-blank value. 1. Returns the first non-blank value. It evaluates the column for the first non-blank entry and returns the corresponding value. 2. Useful in sparse data scenarios. It's especially useful when working with data sets that contain gaps, blank, or null values. 3. Works with an expression. The second parameter allows you to specify a calculation or aggregation to be applied to the column. Example 1. First non-blank product name. Suppose you have a sales table with product name and sales amount columns. You want to find the first product that has a sales amount greater than 0. First non-blank product equal first non-blank value sales product name, sales amount. This returns the first product name where the sales amount is not blank. Example 2. First non-blank date for sales. If you have a sales table with sales date and sales amount, and you want to find the first non-blank date where a sales transaction occurred. First sales date equal first non-blank value sales date, sales amount. This returns the first sales date where the sales amount is not blank. Example 3. First non-blank value in a numeric column. You can also use first non-blank value to return the first non-blank numeric value in a column. For example, if you want to get the first sales amount value greater than 0, first non-blank sales amount equal first non-blank value sales amount, sales amount. This will return the first non-blank non-zero sales amount from the sales amount column. Example 4. Applying filters with first non-blank value. You can combine first non-blank value with calculate to apply filters before evaluating the non-blank value. For example, finding the first non-blank product name in a specific region. First non-blank product North America equal calculate first non-blank value sales product name, sales amount, sales region equal North America. This returns the first non-blank product name in the North America region. Use cases. Use case 1. Handling sparse data. First non-blank value is useful when you're working with data that has missing or incomplete entries. It helps you retrieve the first meaningful value and bypass blank or null values. Use case 2. Dynamic reporting in Power BI reports. You may want to display the first relevant date, product, or metric based